Dear students, welcome to Mathematics Online classes. In this class, we will discuss one more concept which is left out in the maxima and minima, that is maximum and minimum values of a function in a closed interval. Closed interval in the sense, see, in the last class, means in the previous problems and all, what we did, there was no particular interval at all. Here, particular intervals will be given to you, like closed interval from 1 to 5, closed interval from -4 to 3. Like this, one closed interval will be given to you. In this closed interval, what is the maximum value attained by the function and what is the minimum value attained by the function, we need to find out. Let me take a graph here like this. Suppose there is a graph. It is defined from the point 1 to, let me say, 6. 1 to 6. It is defined in the closed interval 1 to 6. Among these values, where it has attained a minimum value and where it has attained a maximum value, we need to find out. Very simple it is. What we do here, we will find out critical points first of all. Critical points means points where slope of tangent is 0. Means this point and this point. We will find out all these points and including the end points of the closed interval, we will find out the functional value. Which one is maximum, that will be the maximum value. Which one is minimum, that will be the minimum value. That this is also called as a absolute maximum value and absolute minimum value. Absolute maximum and absolute minimum values, these are also called as. Okay, once I will write the steps here. Very simple it is. First step is that find critical points. Find critical points, that is points where f dash of x is equal to 0. Points where f dash of x is equal to 0, we need to find out. That is the first step. And second step, what we need to do, take all points. Take all points. All points in the sense where f dash of x is equal to 0, where f dash of x is equal to 0, and end points of interval. And end points of interval we need to take. And now for all these points, means points where f dash of x is equal to 0 and at the end points of the interval, we need to find out the functional value. Find f of x values at all points, at all the points you have taken. This is the third step. And fourth step, which one is maximum among the given values, that will be the absolute maximum value. Which one is minimum among the values you have calculated, that will be the minimum value. Very simple it is. And one more thing you can observe here, is there any 2 or more maximum values or 2 or more minimum values? Means no 2 or more maximum values or 2 or more minimum values. Only one maximum value will be there, only one minimum value will be there. Very simple it is. Let me take an example from the exercise 6.5. That is fifth main. First question I am taking. Find absolute maximum value and absolute minimum value. Find absolute maximum value and absolute minimum value of the function f of x is equal to x cube, where x belongs to the closed interval -2 to +2. One thing you remember, if the interval is given, we need to find out absolute maximum and absolute minimum values only. Okay, what is the first step? Find f dash of x. Differentiating the function with respect to x, f dash of x is equal to differentiation of x square is 3x square. Now f dash of x is equal to 0 at the point x is equal to 0, because f dash of x equal to 3x square. If x is 0, then f dash of x is equal to 0. Simple one. Now what are the points here? Points are endpoints of the closed interval -2 to +2, these 2 points also you should include. Points are -2 and here is 0 and +2. Now what is the functional values? F of x is equal to x cube is the given function here. F of -2 is equal to -2 to the power of 3, answer is -8. F of 0 is equal to 0 cube, answer is 0. F of 2 is equal to 2 cube, this is +8. Now what is the maximum value it is attaining? +8. What is the minimum value it is attaining? -8. Very simple. Now absolute maximum value is 8 at the point x is equal to 2. That's it. And what about the absolute minimum value? Absolute minimum value is -8, which occurs at the point x is equal to -2. Such a simple thing it is, finding the absolute maximum value and absolute minimum value. Okay, this is about the concept. Now in the exercise, in the previous class we were solving exercise 6.5 problems. In that third main 2 problems we did, and now let us take 2 more problems. After that I will move on to the next heading. Okay, in that exercise 6.5, in short exercise 6.5, let us take question number 4th one. Question number 4, exercise 6.5, 5th main, question number 4. What is that? F of x is equal to sin x minus cos x, 0 less than x less than 2 pi. This is the question given. Now this is finding the local maxima and local minima values. F dash of x is equal to differentiation of sin x is cos x minus of differentiation of cos x is minus sin x, minus plus sin x. Now f dash of x is equal to 0. This implies cos x plus sin x is equal to 0. Cos x is equal to minus sin x. If I take cos x to the right hand side, that will become minus tan x. So I can write here tan x is equal to -1. Interval given is 0 to 2 pi. 0 to 2 pi means first quadrant, second quadrant, third quadrant and fourth quadrant, all 4 quadrants. Tan x is equal to negative. Tan x, where it is negative? It is negative in the second quadrant, it is negative in the fourth quadrant. In both the quadrants we need to find the value of tan x, which gives us -1. Now here you see tan x is equal to -1. How will you write in the second quadrant? In second quadrant it will be taken as pi minus of 1 is there, pi by 4. Now this is tan x is equal to tan of, if we simplify, 4 pi minus pi, nothing but 3 pi. 3 pi by 4. X is equal to what? 3 pi by 4. And then tan x is equal to -1. We can write it in the fourth quadrant also. In fourth quadrant how we write? We write it as 2 pi minus, yes, it is 2 pi minus pi by 4. Tan x is equal to tan of 2 pi minus means 2 pi into 4, 8 pi, 8 pi minus pi, it is 7 pi, 7 pi by 4. So what we have? X is equal to 7 pi by 4. This is about finding the local maxima and local minima values. We got the 2 points, x is equal to 3 pi by 4 and x is equal to 7 pi by 4. Now let us check here at which point it has maximum value and which point it has minimum value. For that, what we need to do? We need to go with the second derivative test. Second derivative test, f dash of x is equal to, already I have it as cos x plus sin x. Once again you differentiate. Differentiating the function with respect to x, f double dash of x is equal to differentiation of cos x is minus sin x, differentiation of sin x is plus cos x. Okay, f double dash of x, whether it is greater than 0 or less than 0, at these points I need to find here. Okay, fine. At the point x is equal to 3 pi by 4, f double dash of 3 pi by 4 is equal to minus sine of 3 pi by 4 plus cos of 3 pi by 4. Okay, finding these values, f double dash of 3 pi by 4 is equal to minus sine 3 pi by 4 minus sine of 3 pi by 4, we will write it as pi minus pi by 4 plus cos of 3 pi by 4, we will write it as pi minus pi by 4. Yes, now minus as it is. Sine of pi minus pi by 4 means second quadrant sign is positive. Here plus into minus, this will be minus only, sign will not change, this will be sine only, sine pi by 4. Cos of pi minus pi by 4 means it is second quadrant, cos is negative, put negative, pi is there, even number of 90s, no need to change the trigonometric function, this will be cos pi by 4. See, both are negative, cos pi by 4 is how much? 1 by root 2, sin pi by 4, both are 1 by root 2. This is minus of 1 by root 2 plus 1 by root 2. This will be a value less than 0. F double dash of 3 pi by 4 is less than 0. Therefore, x is equal to 3 pi by 4 is the point of local maxima. Point of local maxima. And local maximum value is f of 3 pi by 4 is equal to sin 3 pi by 4 minus cos 3 pi by 4. Okay, f of 3 pi by 4 is equal to sin of 3 pi by 4. Again we will solve as per the problem we did here. This is like taking pi minus pi by 4 minus cos of pi minus pi by 4. Same way, it will be sin pi by 4 and this minus minus becomes plus cos pi by 4. Sin pi by 4 is 1 by root 2. This one is also 1 by root 2. So answer, if we simplify, that will be root 2. So local maximum value of the function is a root 2. And then at the point x is equal to 7 pi by 4. At the point x is equal to 7 pi by 4 also we will check. F double dash of 7 pi by 4 is equal to f double dash of x is minus sin x plus cos x minus sin of 7 pi by 4 plus cos of 7 pi by 4. F double dash of 7 pi by 4 is equal to minus sin of, how we will simplify? We will simplify it as taking 2 pi minus pi by 4 plus cos of 2 pi minus pi by 4. Now 2 pi minus, this minus outside, let it be as it is. 2 pi minus means fourth quadrant. In fourth quadrant sign is negative, so negative into negative it become positive. Sin of 2 pi, even number of 90s, we should not change the trigonometric function, this will be sin only, sin pi by 4. Next, cos of 2 pi minus, 2 pi minus means fourth quadrant cos is positive, put positive sign only, and again there is no change in the trigonometric function, this will be cos pi by 4. You see, 1 by root 2 plus 1 by root 2, that is nothing but root 2, it is greater than 0. So x is equal to 7 pi by 4 is point of local minima. Local minimum value is f of 7 pi by 4 is equal to sin 7 pi by 4 minus cos 7 pi by 4. F of 7 pi by 4 is equal to sine of 7 pi by 4. We will write it as 2 pi minus pi by 4 minus cos of 2 pi minus pi by 4. 2 pi minus pi by 4. It is fourth quadrant. Fourth quadrant sign is negative. Put negative sign. There is no change in the trigonometric function. Sign will be as it is, minus of cos. In fourth quadrant, cos is positive. Positive into negative, that will be negative only. This is cos pi by 4. Now minus 1 by root 2 minus 1 by root 2, that is minus 2 by root 2, that is equal to minus root 2. Okay, now here local minimum value of the function is a minus root 2. That's all about the problem. Remaining problems I advise you to solve. All those problems are easy only. Now in the exercise 6.5, I will take question number 4. Question number 4 is prove that the following functions do not have maxima or minima. Under that, first one, f of x is equal to e raised to x. See, these functions do not have maxima and minima. How will you analyze this? If you analyze according to the graph y-axis and x-axis, here will be the point 0, 1. When we substitute x is equal to 0, it gives us 1. So how will be the graph? Graph goes like this. You can observe, is there anywhere the f dash of x is becoming 0? F dash of x is equal to always e raised to x only. Is there anywhere it is getting vanished? No, nowhere it is getting vanished. It is always continuous only. So we can say that nowhere it is getting vanished. No, there is no question of a maxima and minimum. What will be the maximum? It is extending indefinitely. What about the maxima? It is extending indefinitely. So we can't say it as local maxima or minima. Very simple it is. So how will you write it? We will write it as nowhere. We can analyze the domain also. Domain of this function is all real numbers. Nowhere f dash of x is equal to 0 for all x belongs to real numbers. Therefore, f of x is equal to e raised to x has no maxima or minimum. Nowhere it has maximum value, nowhere it has minimum value. And now going to the second question. Second question is g of x is equal to log x. G of x is equal to log x. What is the domain of the log x? Domain of the log x is r plus. We should substitute only the positive values here. We should not substitute even 0 also. Only positive real numbers we will be substituting for the logarithmic function. You need to be careful. How the graph of the log x will come? Graph of log x will be there like this. When you substitute x is equal to 1, it becomes 0. So this point is 1, 0. Again, same way as that of exponential function. G dash of x, if you find out, differentiation of log x is 1 by x. Here values we are substituting is only real numbers. For that to positive real numbers. For the positive real numbers, is there anywhere g dash of x is equal to 0? No, nowhere it is becoming 0. So again same way, nowhere g dash of x vanishes. Nowhere g dash of x is equal to 0 for all x belongs to the domain of the function r plus. Therefore f of x is equal to it is not f of x, it is given as g of x. Therefore g of x is equal to log x has no maxima or minima. Third question, h of x is equal to x cube plus x square plus x plus 1. I need to say I need to prove that this function don't have maxima and a minima. Differentiating the function, this is a polynomial function. It is not easy to write the diagram, means it is not easy to write the graph. I am not writing. H dash of x is equal to 3x square plus 2x plus 1. How will you say it has no maxima and no minima? Let me check it. So here what I do, I will bring it to the completing square method. From these two functions, let us take 3 common. If 3 is taken common, this is x square plus 2 by 3 into x, this outside plus 1. I am not taking 3 common from the last term. Now here it is like a is equal to x, second term 2ab is equal to 2 by 3 into x, ax get cancelled, 2 to also get cancelled, b equal to 1 by 3. So this is equal to 3 into x square plus 2 by 3 into x plus 1 by 3 whole square minus 1 by 3 whole square plus 1. You see, first 3 terms are like a square plus 2ab plus b square, 3 into a plus b whole square, x plus 3 whole square, minus of 1 by 9 plus 1. 3 will get multiplied to both the terms, that will become 3 into x plus 1 by 3 whole square minus 3 into 1 by 9 plus 1. 3 ones are 3 threes are 3 into x plus 1 by 3 whole square. Here it is minus 1 by 3 plus 1. If you cross multiply, minus 1 plus 3, it is nothing but plus 2 by 3. What is the domain of this function? Polynomial function it is. So its domain is all real numbers. All real numbers we can substitute. There is no restriction like any in the these numbers should not substituted, these numbers should not be substituted, like that. All real numbers. See now h dash of x is equal to, you check. H dash of x is equal to, is it 0 anywhere? Nowhere it is equal to 0. How it is not equal to 0? See, x plus 1 by 3 whole square is a positive value always. It is always positive value. Can it be negative? No, nowhere it is negative because a square is there. Okay, positive plus positive, it is giving us positive values only. Where it is giving us negative values, where it is giving us 0, nowhere it is giving 0. Even if you substitute x is equal to minus 1 by 3, what happens? When you substitute x equal to minus 1 by 3, this first term becomes 0. 0 plus 2 by 3, again it is a positive value only. It to have h dash of x is equal to 0, this value 3 into x plus 1 by 3 whole square should be equal to minus 2 by 3. How can it be minus 2 by 3? Because square is there. So h dash of x does not vanishes anywhere. Again we will write nowhere h dash of x is equal to 0. We will otherwise you write h dash of x does not vanishes anywhere. Nowhere h dash of x is equal to 0 for all x belongs to the domain. Therefore h of x is equal to x cube plus x square plus x plus 1 has no maxima or a minimum. This is about question number 4. Now let us move on to the question number 5. Question number 5 is that finding the absolute maxima and absolute minimum values. In that first question already we did while explaining the concept of absolute maxima and absolute minima. I took that example. Let us take second one. Second one is f of x is equal to sin x plus cos x. X belongs to the closed interval 0 comma pi. Closed interval 0 comma 5. Now where f dash of x is equal to 0, let us find. F dash of x is equal to, it is cos x minus sin x. Interval given is 0 to pi. 0 to pi means first quadrant and second quadrant. F dash of x is equal to 0. This implies cos x minus sin x is equal to 0. This is nothing but cos x is equal to sin x. If you take cos x to the right hand side, sin x by cos x, that is nothing but tan x. I have tan x is equal to 1. Tan x is equal to positive value. The interval given is only 0 to pi. So first quadrant and second quadrant. In second quadrant tan x is negative. I need to find out only in the first quadrant. tan x is equal to 1 can be written as tan of pi by 4. Therefore, x is equal to pi by 4. Therefore, x is equal to pi by 4. Okay, what are the points here? The points are 0, pi by 4 and pi. These are the 3 points. At these 3 points, I need to find out f of x values. F of 0 is equal to f of it is very easy. Absolute maximum and absolute minimum very easy. Many times they have asked the question for 2 mark. F of 0 is equal to sin 0 plus cos 0. What is sin 0 value? 0. Cos 0 value is 1. So answer is 1. And then what is f of pi by 4? F of pi by 4 is sin pi by 4 plus cos pi by 4. Sin pi by 4 is 1 by root 2. Cos pi by 4 is also 1 by root 2. 1 by root 2 plus 1 by root 2. 2 by root 2. 2 by root 2 is nothing but root 2. And then one more point I need to find out. F of phi. F of phi is sin phi plus cos pi. What is sin pi? Sin pi is 0. Cos pi is minus 1. So answer is minus 1. At f of 0 I have it as plus 1. At f of pi by 4 I have it as root 2. At f of pi I have it as minus 1. Which one is maximum among this? Root 2 is the maximum value and the minimum value is minus 1. Very simple. Therefore, absolute maximum value is root 2 which occurs at the point x is equal to pi by 4. And then absolute minimum value is minus 1 which occurs at x is equal to pi. This is about question number 5. Under the question number 5, second sub question we did. Let me solve one more. Question number 3 I am leaving it to you. Let me solve question number 4. Question number 4 is f of x is equal to x minus 1 whole square plus 3. X belongs to the closed interval minus 3 comma 1. X minus 1 whole square plus 3. Let us differentiate this. Differentiating the function with respect to x, f dash of x is equal to 2 into x minus 1. Now you see how simple is this. Where f dash of x is equal to 0, f dash of x is equal to 0 at the point x is equal to 1. Now what are the points to be considered here? Points are minus 3 and 1. F dash of x is equal to 0 at the point x is equal to 1 and end points is also 1 only. So only 2 points are minus 3 and 1. F of minus 3 means functional value at the point x equal to minus 3 is minus 3 minus 1 whole square plus 3. Minus 3 minus 1 4. 4 square 16. 16 plus 3 is 19. And f of 1 is equal to 1 minus 1 whole square plus 3. 0 plus 3 is equal to 3. Now I have only two values. One is 19, another one is plus 3. Therefore, absolute maximum value is 19 which occurs at minus 3. And what about the absolute minimum value? Absolute minimum value is 3 which occurs at x is equal to 1. This is about absolute maxima and absolute minima. Now let us take question number 6 here. Question number 6 is find the maximum profit. Find the maximum profit that a company can make. If the profit function is given by p of x is equal to 41 plus 72x minus 18x square. Have they given you the closed interval here? No, they have not given you the closed interval. And the next thing is that, are they asking you the local maxima and local minima? No, local maxima and local minima we should not find out. Just they are asking you maximum profit that a company can make. Maximum profit that company can make means we should find out maximum value of this function and minimum value of this function. That's all. What about its domain? Domain is all the real numbers. P of x is equal to 41 plus 72x minus 18x square. It is, we need to solve in general here. Okay. Now here, let me rewrite it. Minus 18x square plus 72x plus 41. From these two terms, let me take the common here. 9 is common, let us take it out. I will take minus 9 common. If minus 9 is common, then it is 2x square minus 8x plus 41, this is outside. 2 is also common here, let me take it. Minus 9 into x square, 2 is outside, x square minus 4x plus 41. Now it is very simple. It is minus 18 into minus 8, x square. A is like x square, a is equal to x, minus 4x, 2ab is equal to 4x, ax get cancelled, 2 1s are 2 2s. So what is b equal to? B equal to 2. So what you do? Add b square, subtract b square. X square minus 4x plus 2 square minus 2 square. This outside 41 as it is. Minus 81 into, first 3 terms are like x minus 2 whole square. X minus 2 whole square minus 4 plus 41. Minus 18 into x minus 2 whole square, minus into minus plus 18 4s are 4 8s are 32, 3 carry, 4 1s are 4, it is 72 plus of 41. Okay, now this is minus 18 into x minus 2 whole square. How much is this? 72 plus 41, 113. Okay. Now finding its maximum value and finding its minimum value, we will go using inequality concept. Here is x minus 2 whole square. What can be the x minus 2 whole square maximum value and minimum value? X minus 2 whole square maximum value is x minus 2 whole square. It can take the values from 0 to infinity. And what about minus 18? Negative value is there. Let me multiply with the negative. Minus 18. Multiplying with negative, sign of inequality changes. Minus 18 greater than or equal to minus 18 into x minus 2 whole square greater than or equal to minus infinity. So I can write here, it is minus infinity less than or equal to minus 18 into x minus 2 whole square less than or equal to 0. There is a term, what is that? Plus 113 also. Adding 113 throughout the inequality. Minus 18 less than or equal to, minus infinity less than or equal to minus 18 into x minus 2 whole square plus 113 less than or equal to 113. Minus infinity less than or equal to minus 18 into x minus 2 whole square plus 113 is nothing but p of x. P of x less than or equal to 113. Now you see they are asking you what is the maximum profit. Maximum profit is 113. It can't, p of x can't take the values greater than 113. Therefore maximum profit is 113. Which occurs at which point? Can we analyze? See, p of x is equal to, I have minus 18 into x minus 2 whole square plus 113. It is a negative value. So even if you give any values for x, it will be giving you negative values only. So maximum value what this function can give is 0. When you put x is equal to 2, this become 0. 0 plus 113. So 113, which occurs at the point x is equal to 2. If you substitute any other value, what happens? Let us check. If I substitute 3 here, this is 3 minus 2 whole square, 1 into minus 18. So it is getting subtracting, from the 113. Yes, fine. Remaining questions we will continue in the next class. Thank you.